That's the piece I want to say. That's the high-level view that I want to put across. And now I'll hand over to Spencer, who's going to take you through how Condusiv and V-locity deal with all this. Cheers, Spence.
Lovely. Thank you very much for that, Roy. We are a 34-year-old software company that rebranded to Condusiv Technologies back in 2012 because we expanded our technology to focus on optimizing these I/O streams in virtual environments to help organizations get 50 to 300% faster application performance on the hardware they already have. Now, you should know that because of our work to solve the I/O problems in virtual environments, Gartner named us Cool Vendor of the Year, sorry Roy, and recommended our deployment with every virtualization initiative. Storage Magazine named us as Storage Software Product of the Year, and our technologies are OEM'd by 9 of the top 10 computer hardware manufacturers in the world, and also storage companies like Western Digital and SanDisk. We've got deep relationships with Microsoft as a gold partner and VMware as a TAP partner. And over the years, we've sold over 50 million licenses of our software worldwide and have enjoyed a 90% footprint in the Fortune 1000. So before we really dive in, let me first set the table with our value proposition to help you understand what we do, and then we'll talk about the problems we solve and see if any of that's applicable to you. V-locity is I/O reduction software. It is a 100% software approach to solving the toughest application performance challenges in a virtual environment on your existing hardware. Now, there's 2 big I/O inefficiencies in virtual environments that plague system performance, with I/O characteristics that are much smaller, more fractured, and far more random than they need to be. It's like death by 1,000 cuts of small, tiny I/O that really can bring performance to its knees. For our customers, it's finding out their systems are processing workloads 50% slower than they should, and in many cases, it's even worse than that. So V-locity solves these inefficiencies where I/O is created, and it provides 2 key benefits. First, it increases throughput on existing systems from VM to storage, and second, it reduces I/O response times. So by having one engine that reduces the amount of write I/O from VM to storage and another engine that reduces the number of read I/Os, our customers typically see anywhere from 50 to 300% faster performance on their most I/O intensive workloads. Now, ESG Labs, an independent analyst group, examined the last roughly 3,500 VMs that tested our software in production environments at over 100 different sites and published these results to show what our software does across a large scale. So here's the first thing you should know. Over half of all systems that evaluate V-locity see a 50% or more reduction in read I/O from VM to storage. But it's not just read I/O. V-locity also reduces write I/O. 27% of systems see a 33% or more reduction in write I/O. In fact, 14% of systems suffer from such high levels of I/O inefficiency that they see a 50% or more decrease in the write I/O. So when you add up all the read and write I/O that we're eliminating at the VM OS layer and offload all of that from the underlying storage system, you'll see that you get big improvements in throughput, response times, and IOPS. In fact, the next slide shows you exactly how much. So you might wonder, how does I/O reduction at the virtual server layer translate to performance when it comes to throughput, response time, and IOPS? Well, here you go. 43% of all systems see a 50% increase in the amount of data they can process in the same amount of time. That's a massive jump in throughput, regardless of whether they're on flash or spindles underneath. As far as I/O response time, and this one should really catch your attention, just 3 gig of available DRAM delivers on average 40% latency latency across all I/O on all systems. Excuse me, just one moment. Apologies for that, had a frog in the throat. So here's another thing that's very interesting. 25% of all systems actually get a 50% increase in IOPS, in IOs per second. You might think that IOPS would go down with our solution because we're eliminating all the small, fractured, random IO that's chewing up your systems with this death by 1,000 cuts. But since we're actually helping to sequentialize the IO streams and serve some IO from DRAM, which is a lot faster, IOPS actually goes up. But why is that? It's because the more storage-hungry applications are more productive and able to do more work in the same amount of time, basically because they're not having to wait so much on the storage. So if you're wondering how a software approach like V-locity can provide such demonstrable gains, it has to do with the extent of the performance penalty from these two big I/O inefficiencies in virtual environments. The problem is that most administrators have no idea how much bandwidth is currently being lost to these issues. So they do what they've always done, and that's take the expensive, temporary break-fix approach of just buying more hardware and over-provision for performance, which masks these problems instead of actually solving them. Now, you might already be aware of the I/O blender effect on the right that mixes and randomizes the I/O streams from disparate VMs at the hypervisor layer before sending out to storage a very random pattern that is much harder to process than sequential I/O. And that's true for Flash, not just spindles. But before we look at that problem on the right at the hypervisor layer, we have to actually start by looking at a very different problem on the left that happens a little higher up the stack at the virtual server layer, where we find the first I/O inefficiency on a Windows VM. And we call it a Windows I/O tax. It's a tax on your performance. And it generates increasingly smaller, more fractured I/O over time. And this causes an IOPS inflation and further amplifies the problem of randomization at the hypervisor layer from the I/O blender effect on the right, because you now have even more noise and more randomization. Now, this Windows problem doesn't usually exist on day one. On day one of a fresh, clean NTF install, the relationship between I/O and data is very healthy and looks like the I/O on the right of the left-hand pane that has an example of 32K contained in a single I/O because it sits at a single address at the logical disk layer. It's a nice, clean, contiguous write and subsequent read if that data gets read. But as time goes on in a Windows environment, the relationship between I/O and data begins to break down into increasingly smaller and smaller chunks, like what you see on the far left. Now, I'm not talking about the physical layer where data lives. In a SAN-connected environment, Windows is abstracted from the physical layer. I'm talking about the logical disk that Windows controls. You see, Windows is never looking for the best allocation to write a file at that logical disk layer. It's only looking for the next available allocation, whether it's the right size or not. The reason it's not a problem on day one is because the next available allocation is always the right size allocation. But as time goes on and that file system matures, files are written, erased, rewritten, and extended, creating a lot of free space fragmentation. So the next available allocation is now rarely ever the right size. So Windows will write part of the file to one address, then split the file and split that I/O in order to find the next available address, fill that, and then split again and repeat until the whole of that file is finally fully written. What this means is that 32K of data that should be written and read as a single I/O gets broken down into 4 chunks or 8 chunks, living at different addresses in the logical disk. And every piece of the file requires its own dedicated I/O operation to process it. So not only does this create an I/O overhead issue for the compute layer, more importantly, it's robbing your throughput down to the storage and making you far more IOPS dependent, more random IOPS dependent than you actually need to be. So it takes much longer than it should to process an average gigabyte of data. Now, it's bad enough if a Windows VM has its own problems sending down a bunch of small, fractured I/O, but it's even worse when it's happening across all your VMs. And all of it hits the hypervisor, where everything is then mixed and randomized by the I/O blender effect. And now you have an I/O profile that couldn't be harder for your storage subsystem to process, because the I/O characteristics aren't just small and fractured. Instead of dealing with small, fractured, random I/O now. So it's the perfect trifecta for bad performance. And here's the thing. Your hardware can do nothing about this except do the best it can to process it. Now, V-locity solves these inefficiencies with two different patented engines. The first engine optimizes writes for more throughput, and the second engine optimizes reads to reduce the I/O response times. So in front of you is the first engine that optimizes the writes. V-locity provides intelligence to Windows about file sizes and helps Windows choose the best allocation at the logical disk layer instead of just the next available allocation. And this helps to stop that I/O from fracturing. It increases I/O density, improves the sequential nature of traffic, and ultimately reduces the amount of I/O required to process a gigabyte of data, since Windows is now processing all writes and subsequent reads in a more contiguous, non-broken fashion. So instead of needing 50,000 I/Os to process a gigabyte of data, you may only need half that, or even less, depending on how bad your system is currently being taxed. Conceptually, it's like this. If you're trying to move a liter of water across the room, you can do that in one of two ways: with 300 shot glasses, or make one trip with a liter-sized jug. And that's what V-locity is doing. It makes sure that Windows writes files to the best allocation so that more data is processed with every I/O operation to deliver more throughput, move data faster, and ultimately reduce the noise and randomization that occurs at that hypervisor layer. To optimize reads and reduce response time, V-locity uses a very different engine. This is a server-side DRAM read caching engine that uses the available server DRAM that you already have. Administrators who think of their DRAM as a precious resource and are concerned about allocating memory for cache really have nothing to worry about, because you don't actually have to allocate any cache. It'll just dynamically use whatever is available. That means it automatically throttles according to the needs of your applications, so you never have an issue of memory contention. Now, you may not think of available DRAM as having much impact, since it's really just a limited amount of capacity, but guess what? It has a huge impact. Just 3 gig of available DRAM reduces response time by 40% on average. The reason we can take such a limited amount of capacity and drive such big gains has to do with two things. First, it has to do with the speed of DRAM that is exponentially faster than any other form of flash sitting below it. Second, it has to do with our behavioral analytics engine that sits right next to the application in the guest operating system, which makes us application aware. And that's what gives us the ability to do the most advanced form of caching possible, because we know exactly what to cache and when, with very little cache churn. Any other caching approaches that sit further down the storage stack need a lot of flash capacity to be effective, because those algorithms really, in comparison, are just guessing at what needs to be in that cache. Now, after our customers see how we're able to drop their response time so significantly and remove that much read I/O with just the available DRAM they already have, that's usually when the light bulb goes on and they realize that if they need more performance before they do anything else, just add a bit more DRAM to the server first and allocate it to velocity as tier 0 for their caching strategy. And with the price evolution of DRAM, its speed and proximity to the processor, it just makes more sense to add more DRAM first and give that to velocity. Now, in front of you is a visual representation to show you what velocity is doing under the hood. On the left, without velocity, the I/O characteristics of your workloads tend to be much smaller, more fractured, and more random. Like we just talked about, far more I/O than necessary is required to process a gig of data. The underlying storage subsystem then starts to get overwhelmed and has to work so much harder than it needs to process these workloads. On the right is a visual of what happens after you start using velocity. You've got both patented engines at work, one to help Windows write files in a more contiguous manner, and the other to serve some of that I/O out of DRAM to eliminate even more I/O from hitting the storage device. And this is quite a useful slide because it shows exactly where our technology sits. We're not a virtual appliance, we're not an agent, and we're certainly not a resource hog. We're a very thin file system driver that runs with near zero overhead, and it's installed right into the Windows operating system on a virtual machine where the I/O actually originates. And since the optimization is taking place at the OS level on the VM, not only does it mean everything downstream accrues benefit, it also means we can be completely agnostic to the hypervisor vendors and the storage vendors who sit below us. As long as they're compatible with Windows, basically, they are compatible with us. Velocity's not changing anything related to an I/O because we never actually touch the I/O directly. It's just an optimized standard Windows NTFS I/O that's still being generated. Now, here are a few customer examples to show the takeaways of what I/O reduction meant for some of our customers. And if you want the full story on any of these, you can go to our website where we have at least 15 different published case studies. So I'll just pick a few out. I won't bore everybody to tears by reading all of these out. But this is a really good one. Christus Health on the top left-hand side. They virtualized all their physical servers running their electronic medical record application, and they started to run into a few performance issues. And they were about to pull the trigger on a $2 million NetApp purchase. But before they did it, they evaluated velocity first and found out that we were able to double their performance. And they actually cancelled the PO for the NetApp storage. And I'm sure that the NetApp guy was quite cross. And we've got Bell Mobility. They had a custom app sitting over SQL that was taking way too long when users tried to generate reports. They tried velocity, and we reduced I/O to the SAN by 61% and tripled the performance of their SQL queries. And finally, Stockport College here in the UK, they were crashing on enrollment day because I/O overwhelmed their systems. They were looking at adding flashcards and upgrading their SAN because on average it was taking 15 minutes to process one student record where the student was trying to enroll. But after trying velocity, that average dropped to just 5 minutes. So because of the success of that, they put us on their payroll job next that were taking about an hour and a half. And we dropped that to 15 minutes. Now, velocity can be evaluated, and that's usually where most customers start. So you can see exactly what kind of performance gains you're going to get in your real-world environment before making any kind of purchase commitment. And we're so confident about this that we also actually offer a no-quibble money-back guarantee. Some customers use their own performance monitoring tool to validate the before and after benefits, but the product does come with its own embedded tool called the Benefit Analyzer. It monitors and reports on your workloads before Velocity is optimizing. Then it collects data during the optimization process and puts together a really clean before and after comparison on all the key performance metrics you would care about, and puts it all into a report form that proves the ROI and provides you with a good commercial justification. And we also have a free, no obligation tool called the Condusiv I/O assessment tool that can troubleshoot your environment and tell you which systems have the most I/O issues, what those issues are, and how big the problem is. Now, we had a lot of internal debate about productizing this and charging for it, but for now we've decided to give it away for free, simply because it's advantageous for us to help you identify I/O issues. Obviously, it's up to you whether you want to turn to a hardware solution for more performance or try Velocity first to solve the problem on the hardware that you already have. Now, some of our customers already know exactly which systems are giving them problems and skip the I/O assessment tool and go straight into evaluating Velocity. But for those who'd like to do some troubleshooting from VM to storage first and see all available performance metrics and highlighted issues about any workload, the I/O assessment tool is the perfect place to start. The assessment tool is very helpful in that it shows you the amount of I/O fracturing that's occurring and whether or not it's at a problematic level sufficient enough to hurt performance. It also supplies an industry-first I/O blender index that cross-correlates performance metrics from all the VMs on the same host to see if there are any spikes that occur at the same time, which would indicate chatty neighbor issues because of the I/O blender, and then tells you how big the issue is. You can see the amount of workload on each system, IOPS, throughput, response time, and other things like queue depth and CPU and memory utilization. The tool shows the averages and peaks for every hour, so you can really dig in at a granular level. And the great thing about this tool is there's no installation process. It's just a simple executable file that you open and run on a system in your network, and you simply point it to all of the systems that you want to monitor. And all it's doing is collecting existing Windows performance data, a bit like Windows Resource Monitor or Windows Perfmon, and then it gives back to you that information in an easy-to-read format, along with our troubleshooting analysis. As you can see, it color codes the systems red, yellow, green, indicating the level of I/O inefficiencies. Then it points out which of the 11 I/O performance metrics might be of concern, whether that's latency spikes, queue depth issues, I/O fracturing, or something else. I should note that this tool is only meant to point out performance issues. It's not going to fix anything. It's also possible and even likely that some systems in green actually do have I/O issues under the surface, but because you're so over-provisioned for performance, you're just not seeing any performance issues on their systems right now, but it will still show you where those inefficiencies are for the future. Also, some systems may come up in green simply because the workload is so light, so it's just not taxing your storage or harming other systems on the same host. So not only does this tool give peaks and averages by the hour, it actually provides some level of analysis to help you identify which virtual servers you should be concerned about and which of the 11 performance metrics are of concern. And we encourage users to run the tool for as long as you want to collect the data. Most people schedule it to run 5 production days from Monday to Friday, and then they will share their data with one of our sales engineers so that we can step you through it and determine if and where Velocity should be evaluated. So that's pretty much it. Just to briefly recap, Velocity is a software-only approach. It saves time by increasing performance 50 to 300%, and also saves money because you can solve the problem without having to buy more expensive hardware. There's a lot of resources available on our website at condusiv.com, We've got things like case studies and white papers and so on. So I hope that's useful. Before we go to the Q&A session, I've seen a few questions have come through. I'm keen to sink my teeth into those, but I think we should just choose the winner of the competition. So let's pull somebody out at random, and it's going to be Antonio Suarez at Fertigus. Antonio, well done, sir. You have won the Surface Pro laptop. Good stuff. That'll be winging its way to you. One of us will get in touch after this session and get the address to send it to. So let's go to the Q&A and have a look at some of these. So, do we need to add memory to take advantage of IntelliMemory? That's a good question. In most cases, no, you don't. In pretty much any Windows system, you will have a portion of RAM which isn't being used by anything else. If you don't, then that system is already going to be very, very sluggish because you will be relying on swapping to the page file. So what V-locity can do is use up to half of what Windows sees as available physical memory. That's memory that's not being used by anything else, and it can create a cache space out of that. And as I mentioned in one of the previous slides, the cache is dynamically sized. So if you spin up a new application that requires a new working set, V-locity will shrink its cache ahead of time and pages back to non-paged port for this new process to use. Now, on an average Windows server, I normally recommend to customers to leave about 4 gig of available physical memory. That would give V-locity a 2 gig cache size, which doesn't sound like much, but because of the telemetry techniques that we have, we can be very, very smart. It will learn over time what applications are in use, what type of data is being accessed, what type of I/O streams are being generated, and at what times of the day, the week, the month, the quarter. So it's very, very smart about what data needs to be in the cache and when, so we can really make the most economic use of that cache space. So I hope that answers that. So Antonio says, hi, V-locity is installed on the VM and not on the hypervisor, correct? So when we have several VMs per hypervisor, how does it eliminate the blender effect between the hypervisor and the SAN? What a great question. Okay, so first of all, yes, you're right. V-locity would be put onto the guest Windows operating systems inside each VM. And there's several reasons for doing that, but one of the most important is that is where the I/O is being generated by the applications and by Windows. And that is the point at which the I/O gets split. And it's important to remember that each I/O that you have to generate takes a measurable amount of time and resource to process. So if you're saving, let's say, for example, a 20 gig file in just a handful of I/Os, that's a much more efficient way of moving that data between server and storage than if you take that same 20 gig file and Windows has split it into 2,000, 3,000 or 4,000 separate I/Os. So because that's the point, that's the layer where the I/O gets split. That's where we put the V-locity technology to prevent those I/Os from being split. You can't do that down at the hypervisor layer because it's too late. The I/O's already been split up into lots of tiny fractured I/O. So how does that eliminate the blender effect between the hypervisor and the SAN? Quite simply, it first of all is reducing the amount of I/O, and secondly, it reduces the randomization because the I/Os are being written out in larger chunks at a time, so that you have fewer I/Os which are bigger, fatter, carrying more data down the storage stack to the controller. And that means that the storage controller can then, it has the opportunity to write larger, more sequential stripes across its media, rather than having that same amount of data in tiny little chunks at a time, which means it has to do a lot more storage level operations to process that same amount of data, because it's now only able to create very small stripes across its media. So I hope that answers that one. Next one is from Paolo, and he says, where can I find the assessment tool? Good question. It's a secret. No, it's not. The IO assessment tool can easily be obtained. You just reach out to your Condusiv account rep. You can get in touch with us via the website at condusiv.com and request a copy. We'll get it out to you very, very quickly. Anybody who wants it, just ask, and we'll get it out to you very, very fast. So we have another question here. We have almost our servers on the cloud, except for business critical servers that require extreme throughput for our ticketing system. If we want to optimize our cloud VM servers, how can we license it? Because we want to have the optimization benefits on the cloud. Another great question. That can certainly be done. The V-locity technology you can have in your data center, you can have completely in your cloud machines, or a mixture of both. And the great thing is you have a single point of command and control, a single management console, regardless of where the V-locity technology is. So yeah, if you've got Windows VM sitting in a cloud, absolutely you can put V-locity in there and optimize those workloads as well. So the next one is, the IO assessment tool is not on the evaluation software download on the website. That's true. Absolutely right. Just send us an email or fill out the inquiry form or get in touch with your Condusiv rep, and we can definitely get that out to you. That's not a problem. So the next one, where can one get the IO assessment tool for free use? Well, I think everybody wants the assessment tool, which is pretty good. Yes, go ahead, Matt.
Hi, just give out my email address, and anybody who wants it, they can email me, and I'll send them the link to download the tool.
Great idea. Okay, so Matt's address is matkinson, ATKINSON, at condusiv.co.uk. Okay, so everybody just deluge his inbox right now.
Right.
Okay, so I think that's, let's see if we've got any others quickly here. Oh, here we go, we've got a couple more coming through. One from Roberto. Is it still a good policy to give free RAM to each VM, something like 2 to 4 gig, to use the Condusiv solution? Yes, it is. I normally recommend, as I mentioned before, have about 4 gig free, which will give V-locity about a 2 gig cache size. That's going to give you a really good return on that investment. But it's worth mentioning, in the very latest version of V-locity, we also introduced a memory compression technique. It has near zero overhead, but what that means is that we can now fit more blocks of data into the same amount of RAM cache space. So even if you are sort of fairly memory strapped, we can now do a lot more with whatever memory you can spare or that you have spare in the machine. And as mentioned before, if you need more performance, the solution is just to add a bit of extra RAM to the server and then allocate some of that to the VMs. Now, that might make some of you fall off your seat and think, oh no, I've got to buy more RAM. But think, what's the alternative? If you need that extra performance, your only other alternative is to over-provision for this excess, unnecessary I/O down at the storage layer. So that typically means you have to buy more spindles to go into the SAN to spread the load of that I/O over a larger number of moving components. It may mean that you have to add a tray of SSD or start adding flash cards. These are all expensive solutions that are not actually fixing the problem. They're just masking the problem by over-provisioning with this expensive hardware. What we're doing with this software-only approach is actually fixing the problem at the source, the operating system layer, where this bad, inefficient I/O gets generated and then bogs down everything below that point in the storage stack. Right. Oh, someone's had put through a question that isn't really a question. They say, yeah, we already use velocity since the beginning, and we do recommend. Well, that's very kind. Thank you for that. Okay, so I think that's pretty much it for the questions. So I'm going to call this to a close. I would just like to thank everybody for attending, and I hope it's been interesting and useful. Roy, do you have any final closing comments?
No, I mean, I think my main final comment here is that it looks like through the questions you've got here that people get this message. I think if you get the message that the first thing you need to do is look at reducing that I/O and optimizing that I/O before you go spending any cash on additional hardware, that's the approach to take. It certainly sounds like your audience today, Spencer, has got that message, and Condusiv as a tool it's not going to impact you. And it's certainly not going to sort of cost you anything else. It's only going to give you reduced I/O and increase the length of time before you need to invest in buying additional hardware. So in effect, it's a win-win situation for you. It's one of those technologies that you very rarely find comes in without a downside. Condusiv is just one of those. It comes in without a downside. It's there. It solves a problem, and it saves you spending money before you need to spend it. So that's, I suppose, my final comment on it.
That's brilliant. Roy, thank you so much for that, and thank you for co-hosting with me today. And to the audience, thank you so much for joining us. I really appreciate your time today, and please do reach out to Matt for that free, no-obligation I/O assessment tool. His email address, again, is matkinson@condusiv.co.uk. So pester him for your free copy now, and he will get it out to you this afternoon. Great stuff. Thank you so much again, and enjoy the rest of your afternoon.